Welcome to the next chapter in this course where we are going to take a look at some best practices for designing REST APIs. This isn't meant to be an extensive list and cover all of the best practices. I just wanted to highlight some of them that I find particularly valuable and I think are worth implementing in a REST API. But first, I have to preface this by saying that you should approach all best practices, even the ones I will share here, with a dose of pragmatism. Maybe some of them don't make sense in your context. Maybe you don't agree with some of them. That is perfectly acceptable. You can pick and choose which best practices make sense for you, and I will do my best to explain why I think they are valuable. The first REST API best practice that I want to share with you is be consistent. Whatever design approach that you choose for your REST API, make sure to keep it consistent. This will make it easier for your clients to integrate with the API, as they will know what to typically expect when they need to interact with a different resource. Your REST API should at the very least support the standard set of HTTP methods. These would be get, post, put, and delete, and from then on you can choose if you want to introduce additional HTTP methods if they make sense in your context. Your REST API should return the correct HTTP status codes, as this will help your clients understand the content of the response, if it was successful or not, and how they can recover and what to do next in case of an unsuccessful response. So far, what I outlined is something that we already discussed in the previous lessons, so now let's move into some more practical examples. A commonly accepted best practice for designing the URIs of your resources is that we want to use plural nouns for representing our resources. In this example, instead of referring to the collection of habits with a singular name, habit, or a single habit with habit / the identifier of the habit, a better approach would be to refer to the collection of habits in plural, as this is really what it represents. So we would be using habits in plural to represent a collection of resources. And then for a single habit, which is this resource here, we would append the resources identifier to form the URI. As with any best practice, there will come some edge case that doesn't really fit the narrative, and in those situations, it is perfectly acceptable to structure your URIs in a way that makes the most sense. The next best practice that I want to share is that you should avoid deeply nested URLs. In this example, any URI that has more than 2 levels of nesting would fall under a deeply nested URL. For example, we have the user's resource, and then we append the user identifier to scope this to a single user. And then we append another resource, which is the habits, and then the identifier of a given habit, and we would interpret the resource so far as a single habit for the specified user. But if we append another level, in this case the entries, then we want to see the individual entries for this specific habit for this specific user. And this might seem like a good idea because you make the user identifier and the habit identifier required arguments in the route, in the URI, but there are other ways to achieve this without ending up with a deeply nested URL. We could implement the same behavior on our REST API by just exposing an entries resource, having a habit identifier as a query parameter, which can also be required, and then the user identifier can be implicit. Our API will almost certainly support authentication, and we can get the user's identifier from a claim present on the JSON web token or cookie. This one might be a little controversial, but you should at least consider it because it gives you a lot of flexibility. And the best practice is that you should wrap your collection responses, arrays, in an envelope. Let's say we have a top-level object with a data property which contains the actual collection. So why do I think this is a good approach? It gives you flexibility. Whenever in the future you need to update or change the structure of this response, you have flexibility to do so. You can append additional properties to the top level of the response without breaking any clients that are already using this resource. If it were a top-level collection resource, just the array of JSON objects in this example, then adding an additional property would be a breaking change. And this is something that you want to avoid, so wrapping your collection responses in an envelope makes a lot of sense because it gives you optionality. On to the next one. You should consider supporting pagination in your collection resources. On a high level, you have two options when it comes to implementing pagination. We have offset pagination and cursor-based pagination. Offset pagination uses an offset parameter to instruct the database how many rows it should skip and then return a given number of rows represented with a limit. You will also see these arguments called skip and take, or page and page size, in which case your API has to calculate the offset based on the page number and the page size. Cursor pagination uses a value called a cursor, which represents the index of the last seen element. And this can be a very interesting approach because it allows you to use some optimizations in your database, mainly an index on a sortable column, to perform an index seek operation, which is significantly faster than offset-based pagination. We are going to explore both of these pagination approaches as part of this course, so don't worry, you will understand what offset pagination is and what cursor pagination is. Another thing I highly recommend when supporting pagination is returning hypermedia links that allow the client to easily fetch the next or previous page of resources. You can also have links to navigate back to the first page or the last page if your pagination approach supports something like that. Now let's spend a moment to discuss a topic that I find very interesting. And this is how we structure our resource identifiers in a REST API and even in HTTP APIs in general. So what am I talking about? A resource identifier, or a URI, which is short for Uniform Resource Identifier, can be whatever you want it to be. Now this is from the definition. A URI is a unique sequence of characters that identifies an abstract or physical resource, such as resources on a web page, a mail address, phone number, books, real-world objects such as people and places, concepts. So the two important things that I want you to take away from this is that anything can be a resource so long as you give it a name, and anything can also be a URI as long as it allows you to uniquely identify a given resource. Now in practice, the most common type of identifier you will see are going to be database-generated sequential identifiers. This is typically going to be an integer starting from 1 or some random seed value, and then this value will be incremented for each new row in the database. The benefit is that it easily allows you to find unique values. It is also naturally sortable in ascending or descending order, but it does come with some drawbacks. For example, in a distributed system, generating globally unique sequential integer identifiers is a tough problem. But something entirely random, like a UUID, is a piece of cake, which is why you will often see UUIDs used in distributed systems. Now, what are some other problems with sequential identifiers? They open you up to enumeration attacks. When someone tries to access a given resource using an integer ID on your REST API, and they get a response that the resource doesn't exist, they can just keep incrementing the identifier by 1 and seeing if you have some security loophole that they can exploit. And this is how an enumeration attack works. A second problem with sequential identifiers is that they expose some sensitive information about your business that your competitors may want to use against you. For example, let's say you have an e-commerce application and you are exposing your orders using sequential identifiers. When somebody creates a new order, the order is assigned an ID, and based on the value, they can try to figure out how many orders you are generating, let's say in a 24-hour period or a 7-day span. And this can be valuable business information. Now, another option that we could consider is using UUIDs. The standard GUID type in C# is a version 4 UUID, and starting from .NET 9, we also have a version 7 UUID natively available, which is a sortable UUID because it uses a timestamp as one of its components. There is also a ULID, which is a very similar data structure to a version 7 UUID because it encapsulates a timestamp and some randomness and is therefore a sortable data structure. And then another option you should consider is generating completely custom resource identifiers. Let's go back to our example of an order. Instead of using a sequential identifier or a UUID, we could make the resource identifier be specific based on the properties of an order. Let's say we have a timestamp, the region where the order was placed, and then some other information, which we can combine to reliably generate a unique identifier. This could be a perfectly valid approach to generating resource IDs. And on top of that, it also adds some business value because looking at the ID, you can figure out some contextual information about the order. Here is something else that you should consider while we are talking about this topic, and that is that you may prefix your resource identifiers with a meaningful value that adds context. In the first example here, I'm using two components, a character, U, and then a version 7 UUID to generate a unique resource identifier. In this example, you can probably figure out that U is short for a user. And this is how we can introduce meaning to our resource IDs. Instead of them being just random UUIDs, which you can't distinguish between a single resource or any other resource in your system, by appending a character or multiple characters in front that convey some meaning that makes sense for your business, you can make the IDs much more valuable. When I look at these, I already know that I should be looking at the user's resource. In this example here, with an H, this can be short for a habit. And I switched the version 7 UUID with a ULID, and this is what I end up with. In both examples, my resource identifiers are sortable, which will make pagination easier, and we are also including some additional context by appending a character that tells us what is the resource that this URI is identifying. If you're wondering who even does this, you may be surprised to learn that all Stripe IDs come with a prefix that explain what is the resource that it's identifying. So you will have prefixes for a payment intent, a user account, a payment method, and so on. So while this is not a standard in most REST APIs, I think it is worth considering. The next best practice I want to share is that you should use a structured error format. This can be anything you like. You can come up with your own error format, but there is a standard called the problem details, which you can use to represent your API errors in a structured way. This is an example of what it looks like. You may notice that the content type of this response is updated to be application/problem+JSON, and it comes with a standard set of fields that communicate what is the error that occurred. In this example, you can see that we got a 404 not found response. We also have a fully qualified URL to the resource that we were trying to access, and we also have some trace identifiers and a request ID that we can use for debugging purposes. If you remember, in the previous chapter, we set up Seek and the Aspire dashboard, which both give us access to structured logs and distributed traces. We can use the information that we get back in a problem details response to easily filter out the specific structured logs and distributed traces for a given request, and then figure out who was the user who sent the request, what went wrong in the system, and then diagnose any potential problems. And I want to finish this lesson by sharing some popular API guidelines that I found while creating this course. And the first one is the Microsoft REST API guidelines. It's in the spirit of REST, even though it is called a REST API, because what they are describing in these guidelines is actually an HTTP API, but I still think you can find valuable information inside of these API guidelines. The guidelines are available on GitHub, and I'm going to share the link right below this video. Now, other than the Microsoft REST API guidelines, there is also the Google Cloud API Design Guide, which is more focused on gRPC, but I think it's still worth exploring because you can always read something interesting that may make sense in your context. The API Design Guide is available on the Google Cloud documentation, and of course I'm going to also leave a link to this API Design Guide right under this video. And then one more resource I want to share with you is the Zalando RESTful API and Event Guidelines. And this is probably the most valuable of the three when it comes to designing REST APIs. It covers many of the best practices that I discussed with you and much more than that. It's a very complete and thought out document, but it's also very opinionated. It's a set of API design guidelines that make sense for Zalando and their company, which doesn't mean it has to make sense for you and your company. So I always suggest approaching these guidelines with a degree of pragmatism, figuring out what makes sense in your context and what doesn't. You don't have to use every best practice that they laid out here. You can pick and choose those that you like. And of course, you can find the links to all of these API guidelines right below this video. Let's slowly wrap up this lesson about the best practices for designing a REST API and move into some more practical topics. In the next lesson, we will finally start writing some code, and we'll begin by introducing our database and configuring EF Core.